Hello, everyone. I'm Kaina Gregorian from Altiminian University. And the paper I will be presenting is about the explainability and legal implications of regression models in transportation domain. First, I will briefly describe the problem, then I will present the background and then the methodology and the results, and we'll finish with the conclusions. So AI models have been very popular and they have been used in academia, in industry to conduct forecasting and predictions and to better understand the relationship between different factors and the target of the interest. AI models have been classified as black box models. An example of black box models are neural networks or reinforcement learning models, where the inner workings and as well as the outcome of the black box models are not very clear. And the second type of the AI models are inherently explainable models, such as regression models, decision trees, or logistic regression, where they are based on simple mathematical formulations and understanding the inner workings as well as the outcome of these explainable models are very simple. Recently, there has been a field in AI called explainable artificial intelligence, as well as in machine learning, interpretable machine learning, that was advocating to develop models that are more clear or provide additional clarification and justification to the AI models where it is difficult to comprehend the model outcome. And specifically, XAI was trying to develop approaches to explain black box models. And formally explainable artificial intelligence is defined as a collection of algorithms that improve the traditional machine learning techniques by providing additional justification and clarification or evidence behind a prediction. So, in the scope of this paper, we are advocating to use explainable AI techniques not only for the black box model, but as well as explainable models, especially when the data is twisted. And for that, we are considering two data sets from transportation domain, and as well as we are showing the need for XAI techniques for explainable models, as well as we highlight some of general legal issues or liabilities generated to the model misrepresenting the prediction. So, why is explainability important? Explainability is important for model debugging, identifying some of the errors associated with the model, detecting biases. For example, if someone was rejected the loan or the CV, were they rejected because of their color or gender or nationality? Also, explainability helps to improve human AI cooperation and strengthen trust and transparency and identify if there was any algorithmic unfairness, as well as to improve the reliability of the model outcome. And finally, it helps to improve the legal compliance and regulatory requirements, where the legal compliance refers to the any standards that is set up by the organization, and it is determined whether the model outcome is set within the boundaries of these legal compliances. There has been many laws and regulations developed to regulate the explainability and the fairness of AI models, such as fair credit reporting and general data protection regulations and California Consumer Privacy Act, as well as Electronic Communication Privacy Act. And the goal of all these laws and the regulations is to make sure that the decisions made by AI is based on more reliable and accurate and justifiable and fair decisions rather than some biased decisions. So there exist many explainable AI methods, and some of these methods are classified as model agnostic or model specific, where the model agnostic means that the techniques can be applied to any machine learning model, while model specific refers to that the XAI technique is within or part of the specific model, such as the decision tree when it's making the decisions. So the technique, XAI technique used in our paper is called a Shapley feature importance, where the feature importance refers to a class of techniques that assigns importance scores to each features. For example, here we have features x1 through x10, and their respective scores are A1 to A10, where, for example, A1 is 0, indicating that feature X is not important for the predictions, and let's say A8 is zero point 0.9 out of 1, meaning that the feature X8 is quite important for the prediction. And the technique that we are using in our paper is based on cooperative game theory, where the goal of the cooperative game theory is to look and understand which coalitions will form. And next, also, it helps to identify how to fairly divide the coalition payoff among the coalition members. And the models used in our paper are regression models and logistic regression, where the first one, linear regression model, has features that have multicollinearity issue, which means that the features are highly correlated with each other. And as we know that if the features are correlated with each other, even the features can be very useful for predicting the outcome, but the results usually will not be very reliable. And so it will be difficult to clearly understand the relationship between the features and the target. So there has been many approaches such as principal component analysis or variance inflation factor developed that address the multicollinearity issue of the regression models. However, none of these approaches are explaining or clarifying the relationship between the features and the target. Therefore, we believe that XAI techniques can be useful in addition to other statistical techniques to provide more explanation and understanding to the relationship between the features and the target. And the next model that we are using is a logistic regression model that is a classification problem with independent features. So from transportation domain, we are considering two specific data sets. One is called SITPOS data set that is looking at different characteristics of a driver, such as the leg length, the arm length, the height of the driver, the feet length, to determine the hip center or how to design the car seat given all these different characteristics of the driver. And the next data set is called US accident data set that takes into account different weather conditions such as humidity, the pressure, the wind speed to predict the accident rates. And so, from these different features, it will be interesting to see which of these features is more important to predict the car seat design or the accident rate. So those are important specifically for the comfort of the driver as well as the safety of the driver and others in the area. So we conduct regression model and logistic regression model. And so we observe first for the SITPOS data set where we looked at the linear regression model with highly correlated features that none of the p-values are significant. So we observe p-values that are statistically very high, suggesting that none of the features that are describing that driver is important to predicting the car seat design. So in that case, we can conclude that none of these features is important. And the next example, the next data set, US accident data set. So we have observed that the p-values are statistically significant. However, the regression coefficient are extremely small. So we have observed that, for example, the weather conditions, such as the wind speed, has an impact factor or effect size, regression effect size 0.001, which indicates that with 1 unit change of the feature within the model affects has very small effect on the target variable. So if we follow these initial results, then what should we conclude? Should we conclude that none of these features is important when explaining or conducting our prediction analysis? But if we looked at the real data, as well as if we look at real world expertise, then we can see that the driver's characteristics as well as the weather conditions are very strong indicators for accident rates, as well as when we're designing the car seat. So to reduce what can be some of the issues associated if we are not following the if we follow the regression model results, that none of these features are significant. So some of the legal issues that we can encounter is a harm to physical integrity or security problems, which is the security damage that could arise if we are following the model that has mispredicted or misrepresented the actual results. For example, if we still drive the car in a weather condition that is like heavy snow, heavy rain, and we just continue advising the drivers that so they will continue driving with the same speed as in a regular, like when the weather is clear and no precipitation is has been recorded. And if we continue in this case, and if there is damage recorded, so this will increase the rate. Like if we look at the real world data, then it will show that this will increase the physical damage by at least 27%. So the next legal issue that we can encounter is the misuse of the data. So by looking at the results that are not statistically significant, then we can intentionally or unintentionally suggest that this data is not useful. So this will be the misuse of actual data that could be very important for our production and manufacturing. And the final aspect is lack of accountability and responsibility of the machine learning model results, such as like who will be responsible. There are, let's say, 50 people that have developed a model, such as software engineers, and there is production involved, there is manufacturing. From legal point of view, everyone involved in the outcome and the decision will be taken into accountable. However, this can be very difficult, and more analysis will be necessary to identify the real cause of the error and the contributors to the final decision making. So to avoid or to reduce some of these issues, we can add like other techniques such as Shapley net effects, that is an explainable AI feature importance measure technique to identify which of these features are more important when designing the car seat or when determining the accident rates. So, what is Shapley value feature importance? It's based on cooperative game theory that helps to identify features' contribution to the model performance. And the initial part of the algorithm is evaluating different combination of the models using the raw data. For example, if we have like three features, then we can construct six different models by using our variables, and from these all different combinations, then the next part of the algorithm is extracting like or removing some of the variables from the models and evaluating how the model performance is changing after we're removing some of the models from some of the features from the model. And based on that, we can determine the feature importance values based on their marginal contributions. So after following these steps to determine feature importance values, we have observed following explainable AI feature important results for two of the data sets that we have analyzed. The first one shows the seat post data sets, and it shows the leg length and the height of the driver, as well as the height of the driver's seat is three most important features when designing the car seat. And next, we have the US accident data sets where it shows that the wind and the temperature are the two most important factors for that is contributing. Finally, we can observe that like XAI methods can be very important to provide additional clarification and justification to the AI model that has been developed. So this suggests that even like XAI explainable models already come with explainability. However, if the data is twisted, such as the features have multicollinearity issue, so we may still observe non-reliable results due to these high correlated variables. And the second case, which we looked the U.S. accident rates, again we have observed that data was not very reliable, and this is probably due to omitted variable bias. That maybe some important feature was not included in the variable. That's why the regression coefficient were so statistic non had such a minor significance for the prediction. And XAI methods will help to provide additional information and clarification about the relationship between the target and the features. So to improve the work as a future work, we want to include further legal side discussions that will provide more specific issues and liabilities, as well as more information about the legal consequences of the model misprediction. And also, we hope to include different types of XAI techniques rather than just the Shapley net effects. And we would like to include some popular techniques such as Lime or the SHAP, and we will see how these other techniques will provide additional information or different types of explainability to these models that have been developed. So this is the end of the presentation. I'm thankful for your time, and so here are the references included in our paper. And please let me know if you have any questions or about the paper. Thank you.